Let a function from the real numbers to the integers be defined by c of x equals a ceiling of x minus 2. Is c 1 to 1? Is c on 2? Explain why or why not in each case. So for 1 to 1, we know that if c of x is equal to c of y, if and only if x is equal to y. For us, let's do a counterexample. So let x equal 2.1, let y equal 2.2. C of 2.1 is equal to the ceiling of 2.1 minus 2, which is a ceiling of 0.1, which is equal to 1. And the ceiling of 2.2 is ceiling of 2.2 minus 2, which is equal to ceiling of 0.2, which is also 1. So we have c of 2.1 equals c of 2.2, but 2.1 does not equal 2.2. So we have this, but we show that x does not equal y. So therefore, it is not 1 to 1. Now for onto, the ceiling function gives you integer values. Okay. So the range of c of x is all integers. So to see that to answer the question, is it onto? Well, the range here, or the codomain rather, matches the range. So therefore, it is onto. Now we want to see whether c now from integers to integers defined by c of x equals the ceiling of x plus 2 is bijection. So for bijection, it means it's 1 to 1 and onto. So for 1 to 1, if I have c of x equals c of y, then that's if and only if x equals y. So my input here is all integers. So for example, if x equals 1, c of 1 is a ceiling of 1 plus 2, which is a ceiling of 3, which is 3. So the idea is if I put an integer inside here, my answer is going to be the same integer. So integer in means integer out. So if I find c of x, that's just the ceiling of x plus 2. If that's equal to the ceiling of y plus 2, both of these guys are integers. So the ceiling of those are just what's inside the ceiling. So we say x plus 2 is equal to y plus 2, which means x has to equal y. And so this is 1 to 1. Now for onto, we know that the range of c of x is all integers. So that matches with this, the codomain. So therefore, it is onto. And because it's 1 to 1 and onto, it's also a bijection.